SpaceX's Dragon just did something that makes NASA's legendary shuttle look ancient. 19 days in space versus 18 days maximum. But that's not the crazy part. Dragon can stay docked for 210 days. That's 15 times longer than Shuttle ever could. But how did private spacecraft technology just completely demolish what was once humanity's crown jewel? And why did SpaceX even do it? Let's dive right in. June 25th, 2025. SpaceX's Dragon capsule launched with Axiom Mission 4. But what happened 18 days later changed everything we thought we knew about spacecraft engineering. For decades, NASA's space shuttle dominated human spaceflight. 18 days maximum mission time. That wasn't just a guideline. It was a hard deadline written in physics. Cross that line, and astronauts would literally run out of air to breathe. Why? The shuttle was designed like a camping trip. Oxygen tanks, food packages, water containers, lithium hydroxide cartridges for CO2 removal. Everything crammed into every available corner. When supplies ran out, the mission was over. Period. But on July 14th, 2025, something unprecedented happened. Dragon hit day 19 and kept going. The question burning through NASA's corridors wasn't just how, it was why didn't we think of this? Here's what makes Dragon's survival possible. ECLSS, Environmental Control and Life Support System. But this isn't your grandfather's life support system. Think of the shuttle's approach like a gas tank. Once empty, you're stranded. Dragon's ECLSS works like a recycling plant that never stops producing. The magic happens through constant automation. Dragon's sensors monitor oxygen and nitrogen levels every second, automatically adjusting the perfect mix. Carbon dioxide builds up. The system doesn't just filter it, it processes and recycles it. Temperature fluctuates, humidity changes, all controlled without human input. But here's the breakthrough that left NASA engineers speechless. Redundancy without bulk. The shuttle needed backup systems for backup systems, each adding weight and complexity. Dragon builds intelligence into every component, turning potential failures into self-correcting events. Those lithium hydroxide cartridges that crippled the shuttle? Dragon carries just enough for 10 days, designed to be swapped as needed. No waste, pure efficiency. And the result? Dragon can stay docked at the ISS for 210 days. That's not a typo. 7 months, 15 times longer than the shuttle ever dreamed possible. Let's break down what this really means. The shuttle's life support system was essentially a countdown timer to catastrophe. 18 days meant 432 hours of survival, then death. Dragon? While docked, it becomes a parasitic organism, feeding off the ISS's life support while conserving its own resources. But here's the genius move. It can power down sections of its life support to reduce strain, then instantly wake up as a fully functional lifeboat if needed. This isn't just impressive engineering, it's revolutionary thinking that makes NASA's approach look ancient. The shuttle was built like a sprint runner, designed for short bursts. Dragon is built like an ultramarathon champion, engineered for the long haul. Why does this matter? Because every day in space costs millions. The shuttle's 18-day limit meant paying launch costs for severely restricted research time. Dragon's 210-day capability changes the entire economic equation. But Axiom Mission 4 wasn't just about staying up longer. This crew conducted over 60 scientific experiments, the most ever on a private mission. Biomedical science, agriculture, advanced materials, neuroscience, space technology, fields that could reshape life on Earth. And here's what makes this even more shocking. Scientists from 31 countries contributed to this mission. 31 nations working together on a private spacecraft that just demolished everything NASA built. The crew itself made history. Shubhanshu Shukla from India, Sławomir Uznański from Poland, Tibor Kapu from Hungary, each the first astronaut from their country to reach the ISS. Not on a government mission, but on a private spacecraft that redefined what's possible. But wait, there's more. Dragon's IVA suits aren't just protective gear. They're integrated life support extensions that work in perfect sync with the spacecraft systems. Cabin depressurization, the suits provide backup cooling and life support. Abort scenario, they become part of the emergency response system itself. Here's what the space industry doesn't want you to know. Dragon's extended capability isn't just about science, it's about economics, and it's crushing traditional aerospace. Every day the shuttle spent in space cost approximately $450 million in total mission expenses. Dragon's 210-day capability slashes the cost per day of space research by orders of magnitude. More science per dollar, more experiments per launch, more return on investment for every mission. This economic revolution is why private companies are racing to build commercial space stations. The math finally works, and Dragon just proved it with real numbers. Axiom Space is building their commercial station with the first module launching no earlier than 2027. Blue Origin's orbital reef promises to house 10 people with internal volume matching the ISS. Starlab and Northrop Grumman are developing competing stations. All of them depend on spacecraft that can support extended missions. Dragon didn't just break records. It proved the business model that will dominate space commerce. But here's the real secret sauce. Fault tolerance through simplicity. The shuttle's complexity meant more failure points. Dragon's approach builds systems so intelligent they prevent problems before they happen. The spacecraft's life support doesn't just have backup systems, it has predictive systems. Sensors detect anomalies before they become critical. Software reroutes functions automatically. Hardware designed to degrade gracefully rather than fail catastrophically. This represents a fundamental shift in engineering philosophy. The shuttle was built to be perfect. Dragon is built to be resilient. And in the harsh environment of space, resilience beats perfection every single time. The integration with Dragon's life support suits proves this point. During launch and re-entry, these suits don't just protect astronauts. They become part of the spacecraft's life support network. It's like having a second spacecraft wrapped around each crew member. When Dragon undocked from the ISS after 19 days, it wasn't just completing a mission. It was completing a transition that began decades ago, but nobody saw coming. The era of government-dominated space exploration officially ended on July 14, 2025. Private companies now lead innovation, drive progress, and set the standards that government agencies scramble to match. SpaceX provides the transportation. Axiom Space provides the missions. Dragon provides the capability that makes it all profitable. This isn't cooperation, it's commercial space completely outpacing government bureaucracy. The shuttle represented humanity's first steps into routine space access. Dragon represents humanity's leap into space commerce, space tourism, and space civilization. But this is just the beginning. With Dragon proving extended missions aren't just possible but profitable, the infrastructure race is exploding. China's Tiangong station is expanding. Private American stations are preparing to replace the ISS. The competition isn't just technical anymore, it's economic, and Dragon just proved private spacecraft technology has officially surpassed government capabilities. The question isn't whether Dragon is better than the shuttle. Dragon has made the shuttle obsolete. The real question is, what impossible breakthrough will private space companies achieve next? Because if 19 days versus 18 days seems like a small difference, remember this, that single day represents the moment private innovation left government space programs in the dust. Forever. And we're just getting started. So there you have it, one day. Just one single day beyond the shuttle's limit. And Dragon didn't just break a record, it shattered an entire era of space engineering. We're witnessing the exact moment when private innovation officially surpassed government capabilities. The student didn't just become the teacher, they redesigned the entire classroom. But here's what keeps me up at night. If Dragon made the shuttle look ancient with just 19 days, what happens when Axiom's commercial station launches in 2027? What happens when Blue Origin's orbital reef houses 10 people permanently? We're not just watching the end of NASA's dominance, we're watching the birth of space commerce, space tourism, and maybe even space civilization itself. The real question isn't whether private companies will dominate space. That battle's already over. The question is, are we ready for what comes next? What do you think? Is this the beginning of humanity's true space age, or are we moving too fast? Drop your thoughts below. I genuinely want to know where you stand on this revolution. And if you're as fascinated by this space transformation as I am, we've got more incredible stories coming that'll blow your mind. The future of space is happening right now, and you don't want to miss what's coming next. Game over! SpaceX just revealed Starship's drone ship legs landing, and it changes everything. How is this even possible? Everyone thought Mechazilla arms were the only way, but SpaceX just dropped a bombshell. A 400-foot Starship landing on floating platforms with deployable legs? The FAA reveals 145 flights per year on drone ships worldwide. But why did SpaceX do this? What makes it so special? Let's dive right in. Here's the problem nobody talks about. SpaceX just announced 145 Starship flights per year. Let that sink in. The entire global space industry launched 223 rockets total in 2024. SpaceX wants to fly Starship more than half that number with a single rocket design. But here's the twist that breaks everyone's brain. Most of these won't be landing back home. Think about it. Every rocket faces the same brutal physics problem. You can either save fuel to fly back to your launch site, or you can use that fuel to carry maximum payload. There's no middle ground. It's like choosing between a sports car that looks fast or one that actually goes fast. You can't have both. For Falcon 9, this choice is manageable. The booster weighs 25 tons and needs about 30% of its fuel to return to the launch site. But Starship? We're talking about a 100-ton vehicle that's 4 times heavier. The fuel penalty for returning home would cripple most missions. So what's SpaceX's solution? Don't come home at all. Here's the problem nobody talks about. SpaceX just announced 145 Starship flights per year. Let that sink in. The entire global space industry launched 223 rockets total in 2024. SpaceX wants to fly Starship more than half that number with a single rocket design. But here's the twist that breaks everyone's brain. Most of these won't be landing back home. Think about it. Every rocket faces the same brutal physics problem. You can either save fuel to fly back to your launch site, or you can use that fuel to carry maximum payload. There's no middle ground. It's like choosing between a sports car that looks fast or one that actually goes fast. You can't have both. For Falcon 9, this choice is manageable. The booster weighs 25 tons and needs about 30% of its fuel to return to the launch site. But Starship? We're talking about a 100-ton vehicle that's 4 times heavier. The fuel penalty for returning home would cripple most missions. So what's SpaceX's solution? Don't come home at all. Let's break down what 145 annual flights actually means. SpaceX's Falcon 9 is already the world's most flown rocket with over 100 launches per year, but Starship carries 5 times more payload. Do the math. We're talking about more cargo to space in 1 year than the entire history of spaceflight combined. Here's where it gets crazy. The FAA documents reveal landing zones spanning from the Pacific to the Indian Ocean. This isn't just about rocket recovery. It's about creating a global space transportation network. A Starship could launch from Texas, deliver cargo to the International Space Station, then land on a drone ship near Australia. Another mission from Florida could service lunar operations before touching down in the Pacific. But executing this vision requires something unprecedented, a fleet of next-generation drone ships positioned around the globe. These aren't the relatively small platforms used for Falcon 9. We're talking about massive vessels, possibly 3 times larger, equipped with precision guidance systems and specialized handling equipment. Here's where SpaceX's strategy becomes devastating for their competitors. While Blue Origin is still trying to reach orbit, while China experiments with net-catching systems that look impressive but face massive scaling challenges, while Europe's Ariane 6 doesn't even attempt reusability, SpaceX is building a global recovery network. The technical barriers are enormous. These drone ships need to operate thousands of miles from shore, navigate complex international waters, coordinate with global logistics networks, and catch rockets that dwarf anything that's ever attempted ocean landing. The investment required is staggering. The expertise needed doesn't exist anywhere else. But here's the kicker. SpaceX already has the foundation. They've been perfecting drone ship operations for nearly a decade with Falcon 9. Booster B-1067 just completed its 29th landing, a record that seemed impossible just 5 years ago. Now they're scaling that expertise to a vehicle 4 times larger and infinitely more complex. The FAA documents reveal something called horizontal Starship delivery. After landing vertically on the drone ship, Starship would be gently lowered to horizontal using specialized equipment right on the platform. This solves multiple problems simultaneously. First, it reduces stress on the vehicle during ocean transport. A horizontal rocket is much more stable in rough seas than a vertical one. Second, it enables faster turnaround times. Instead of waiting for one drone ship to return to port, SpaceX can position multiple ships in rotation. While one is sailing back with a recovered Starship, others are already in position for the next missions. Think about the implications. This creates an assembly line of space transportation. Launch, land, recover, refurbish, repeat. The economic efficiency could drop launch costs to levels that make entirely new industries possible. Space manufacturing, orbital tourism, asteroid mining. These aren't distant dreams anymore. They become practical business opportunities. But here's the detail that exposes SpaceX's true long-term thinking. Every challenge they're solving for drone ship operations directly applies to Mars missions. Landing legs that can handle Earth's harsh ocean environment will be essential for Mars operations where there's no infrastructure. Precision guidance systems that can hit a moving target in rough seas will be crucial for landing on an alien world with no GPS or ground control. The horizontal transport system being developed for drone ships could revolutionize how equipment is moved on Mars. The international cooperation required for global drone ship operations is practice for the unprecedented coordination needed for interplanetary missions. SpaceX isn't just building a rocket recovery system. They're developing the technology foundation for making humanity a multiplanetary species. And they're doing it under the cover of what looks like a simple upgrade to their existing operations. Based on current development indicators, we could see the first Starship drone ship landing as early as late 2025. But that's just the beginning. The real revolution starts when multiple drone ships are operating simultaneously, creating a global network of landing platforms. The infrastructure required is massive.